Okay, hello everyone. In a new video. In this one we are going to solve an exercise related to electricity in the chapters of DC voltage, resistors and electric power and energy. This exercise was a previous one in the previous exams in 2012 first session, second exercise. The title of this exercise is heating plate. A heating plate carries two inscriptions. The first is 220 volts and the second is expressed in watts, but its numerical value is erased. The characteristic current voltage curve of this heating plate is shown in figure 2. They mentioned figure 2, then now we can use it. Number 1, give the physical significance of part A, 220 volts. Then in other words, we need to give the meaning of this indication. So it is rated because it has the unit of volts, so it's the rated voltage of which electric component or electric appliance of the heating plate under which it functions normally. Now part B, the erased inscription. So this is rated. Now because it is expressed in watts and we know that the watts is the unit of power, so it is the rated power consumed by the heating plate under which it functions normally. Now in number 2, they are telling me part A, this plate acts as a resistor, justify. In order to justify why this heating plate acts as a resistor, we need to refer to the characteristic current voltage curve of figure 2. Notice that the shape of this curve is straight line passing through the origin, which means that it is a resistor. Since the characteristic current voltage curve is a straight line passing through the origin, then this heating plate can be considered and now in part B they are telling me determine the value of the resistance R of this resistor. So in figure 2 we have the curve plotted in the current voltage, so we can determine the value of R of this resistor using the slope method. So this slope method consists of 4 steps. The first step is given by that we write the definition. Okay, the resistance of the resistor is equal to the slope of the characteristic current voltage curve Then the next step is to choose 2 points that belong to this curve. Let's choose this point, which is the point A, and this point, which is the point B. Now the coordinates of the point A are given by 2 amperes and 110 volts. Always, all numbers in physics must have a unit. So here 2 amperes and 110 volts. Notice that these numbers don't include any unit because the unit is already labeled here in the axis. Now as for the point B has a current of 4 amperes. And for the voltage of the point B is given by 210 volts. Now the next step is to convert these quantities to the SI, but they are already in the SI. Now finally the last step is to calculate the resistance R, which is given by the voltage of the point A minus the voltage of the point B, divided by the current of the point A minus the current of the point B. Now the voltage of the point B is given by 110 volts because volts is the unit of voltage, minus the voltage of the point B, which is 220, divided by the current of the point A, which is 2, minus the current of the point B, which is 4. Plugging this on the calculator, then the resistance is given by 55. Since everything in the SI, so the value of R will be in the SI, which is ohms. Then R is equal to 55 ohms. Now part 3. Part A, referring to figure 2, give the value of the current carried by the heating plate during normal functioning. So we need to determine the value of the electric current while normal functioning. In order to determine the value of the electric current I, using this curve, we need to know the value of the voltage U. But here, because they are telling me under normal functioning, then the value of the voltage is given by U is equal to 220 volts, because this inscription represents the rated voltage under which the lamp functions normally. And because we need to use the graph, this curve, in order to determine the value of the electric current, then we must write it graphically. So usually they give half a mark for this statement. Now for U is equal to 220 volts, how do we determine the value of the electric current? We have 220 volt correspond to this point on the curve, which has an electric current given by 4 amperes. So we have I is equal to 4 amperes. Then the value of the electric current I is given by 4 amperes. Now in part B, they are telling me deduce the power consumed by the heating plate during normal functioning, and deduce means that we need to use the part just previously before. So in part A, we have determined the value of I corresponding for U under normal functioning. Then the power here that we will be calculating is the electric power under which the heating plate function normally, because it corresponds for the rated voltage and the electric current under normal functioning. The electric power is given by U times I. The value of U is given by 220 and the value of I is given by 4. Plugging this on the calculator, it will give me 880. Since both U and I are in the SI, so the value of P will be the SI, which is watts. So P is equal to 880 watts. I repeat. So in this case, what does P represent? P represents the rated power consumed by the heating plate under which it functions normally. Then in this case, they are telling me in part C, give them the numerical value corresponding to the race inscription. The numerical value is given by 880 watts. Now in part 4, they are telling me the heating plate is used for 4 hours per day. So T is equal to 4 hours. Determine the energy in kilowatt hours consumed by the heating plate during 1 month, 30 days. So here it seems that they are asking me about the electric bill. Then let's write the steps of the electric bill. Step 1 is to convert the power to kilowatts. Step number 2 is to calculate the electric energy E1 per 1 day. Step number 3 is to calculate the energy E for 1 month. Then step number 4 is to calculate the cost. Now in part A, they are asking me about the energy in kilowatt hours, and kilowatt hours can be decomposed into kilowatts multiplied by hour. So the power must be in kilowatts and the time must be in hours. So they are asking me about the electric energy consumed per 1 month. So they are asking me about step number 3. In order to do step number 3 first, we must go through steps 1 and 2. Then the power, which is given by 880 watts, must be converted to kilowatts. In order to convert from watts to kilowatts, we simply divide by 1000. Then dividing 880 by 1000, then the power is given by 0.88 kilowatts. Now step number 2 is to calculate the electric energy consumed per 1 day. We are done with the step number 1. Part A, they are asking me about step number 3. So first we need to perform step number 2, which is the electric energy consumed per 1 day. The formula of the electric energy is given by P times T. So P must be in kilowatts and the time in hours. So the time is given by 4 hours per day. For this reason, E1 represents the electric energy for 1 day. Now plugging this on the calculator, it will give me 3.52. And the unit is kilowatt hours because P is in kilowatts and time is in hours. Now we are ready to calculate the monthly consumption. The monthly consumption is given by E is equal to E1 times number of days. Now E1 is given by 3.52 and the number of days per month is given by 30 days. Plugging this on the calculator, it will give me 105.6. Since E1 is in kilowatt hours, then E will be in kilowatt hours. Then the monthly consumption is given by 105.6 kilowatt hours. Now in part B, they are telling me to determine the corresponding monthly cost, knowing that the average price of the kilowatt hour is 100 Lebanese liras. Then the monthly cost is given by E times the price, which is equal to 105.6 multiplied by the price, which is given by 100 Lebanese liras. So the cost is given by 10,560 Lebanese liras. And by this we have finished solving this exercise. Hope it was beneficial for you guys out there watching it, and see you soon in another one.